Hey guys, welcome to my channel. I go by Hiram or Bogwa. Hey guys, welcome back. So today I will be covering the binary search algorithm. If you haven't watched any of my other algorithm videos, go watch them first. I have the selection sort algorithm and I also have the bubble sort algorithm. Also, if you're new to Java, you might want to start with my Java Fundamentals series before jumping onto this. So now to begin the binary search algorithm. First, I've created my binary search class. And in this class, I have the list of data. Now, this is similar to what I used in my selection sort and also bubble sort algorithm. But in this instance, it's already sorted. Now, the thing to know before you use the binary search algorithm is that you need your data sorted, whether it's increasing to decreasing order or decreasing to increasing order. If you want to, you can pause the video right now and write the same code if you want to follow along and just kind of like read the code. All this does is it prints that list of data. And then next, I've defined here a check. So in order to run this program, you will need to pass at least one element. Now this would be like the number that you'll be searching for in this list. I want to make sure at least you've passed one number before you can execute the binary search algorithm. Now, the number that you pass, since the main method takes in a string array, we'll convert that first to an integer. We'll search for that number using the binary search algorithm in this list, and then return the index that the value was found at. So with that, here I've defined a static method, and I'm calling it binary search, and it's going to return an integer. Right now I'm returning -1. So before I write the binary search algorithm, let me explain it a little bit. What we're going to do is we're going to define an index left and we're going to define an index right. So we have one index pointing to this and another index pointing to this. And what we're going to do is we're going to find the middle of those two indexes somewhere around here. And then from there, you can compare, does the value that we're searching for, first of all, does it equal this index or does it equals this index or does it equals this? You know, the middle index we can find just by adding those two and dividing by 2, right? So that's how we find the middle index. If it equals either one of those, then we know we've already found the index that we have, right? So we can return that index. If not, then what we need to do is we need to determine the value that we're searching for. Is it greater than this middle index that we're at? We know if it's greater than this middle index that we're at, then we know we need to search towards the right. If it's less than, well, if it's less than this middle index value, then we need to search to the left. And that is why it's important to have your list sorted before you run the binary search algorithm. The binary search algorithm will only work if your list is sorted. Now, let's say we're searching through 1 million records. Now, that's where you'll start to see the difference between binary search algorithm and maybe something like a linear search algorithm. Because a binary search will be able to cut by half from the start, right? I'll be able to cut a 500,000, so I don't have to do that comparison. While a linear search, you will need to go through all the elements in order for you to get to the number that you're looking for. So with that, let me go ahead and get started and write the binary search algorithm code. There it is. We have our binary search algorithm. So I'll go ahead and compile this class and run it, and then I'll break it down for you. As you can see, here we're able to see 4 was found at index 3, 3 was found at 3 was found at index 2. And let me add one more print line statement. Okay, let's compile it and run it again. Now here, as you can see, whenever we're searching for digit 3, we move the middle 1, 2, 3, 4 times before getting to our value. Now let's say if we're looking for 20. Now as you can see, whenever we're looking for 20, we just move the middle 1, 2, 3. So we do it 3 times and 3 checks we're already there at 20. Compared to the linear algorithm, we'd have done 1, 2, 3 all the way down until we got to the element 20. So this is the benefit of the binary search algorithm. It simplifies how many times we have to run comparison checks. So now let's look at the algorithm itself. I'll start by defining my left index to 0 and my right index to data.length minus 1. So in this instance, I'm setting the right index to the last element. So for my while loop, I'll do a comparison. Is left less than right, right? If it is, we'll go ahead and execute this code. And I start by calculating the middle, which is left plus right divided by 2, right? So in this instance, it's just going to be the length of this list and then divide by 2 and now get to the middle element, right? So that's why in the first instance, we're seeing that middle is always 6. Middle is always 6. And then after that, we check, hey, is the value that we're looking for at either one of these indexes, right? Is it at left? Is it at right? Is it at middle, right? And if it is, we'll go ahead and return. If it's not, we'll come here and do this check. Is the element that we're looking for less than the middle, right? If it's less than the middle, or the middle is greater than the value that we're looking for, then we need to move that right index to the middle, right? And if that's not the case, if it's greater than the middle, then we need to move the left to the middle. So we're just shifting the left index to the middle. So the important things to know about binary search algorithm is that first, your data should be sorted in order. And then second, it works by dividing the list in half and operating on that half and then dividing it into another half, like continuously until it gets to the value that it's looking for. And with that, that is the basics of a binary search algorithm. Thank you for watching my tutorials. Give it a thumbs up if you like it and subscribe if you haven't. And also check me out on Instagram at coderush.io.